Welcome to the Deep Dive. If you've been following AI development, well, you know we've moved way beyond simple scripts.
Oh yeah, far beyond.
We are now dealing with these really complex probabilistic systems, autonomous agents, basically. They make decisions, run multi-step plans, all to hit some goal.
And that leap, from predictable code to this kind of probabilistic behavior, it creates a huge challenge for anyone trying to build or deploy these things.
Right.
So today we're going to dig into AI agent evaluation. It's the systematic way we measure how these agents perform, looking at their technical skills, sure, but also how safe their autonomy level is, and crucially, the actual business results they deliver.
And our mission here is to give you the frameworks, the strategies, really shortcut you to understanding how to evaluate effectively.
Yeah.
Because, let's face it, if you try using old-school software testing, where you expect the same output every single time, it just won't work. These agents adapt too much. They're too context-sensitive.
They're non-deterministic. That's the key. And that's why a good evaluation has to meet what we're calling the triple challenge. You need, 1, deep technical rigor for the builders.
Makes sense.
2, you need robust safety and ethics oversight. That's for the risk managers. And 3, clear, demonstrable business value for the executives paying the bills.
And if you miss one of those pillars,
then your agent just isn't ready. Simple as that. It's not ready for the real world.
Okay, so let's unpack this. Before you can evaluate anything, you have to know what it is, right? You need to classify it.
Exactly. You wouldn't evaluate a junior programmer the same way you evaluate a CEO. Different roles, different metrics.
So what are the categories? The source material gives us 3 frameworks kind of layered on top of each other.
That's right, 3 complementary frameworks. First up, the classical AI agent types. This is about the core logic, like how the agent actually makes decisions.
Okay.
You start basic, like a simple reflex agent. Think often rules based on what it sees right now.
Like a thermostat?
Sort of, yeah. Then it gets more complex. Utility-based agents weighing trade-offs, and eventually learning agents.
And I assume the evaluation gets trickier as you move up that scale. Testing a simple IFIN rule seems straightforward.
It is. You just check if the rule is correct. But for a learning agent, oh boy.
What changes?
You're not just checking correctness anymore. You're measuring its improvement over time. How well does it generalize? Can it handle stuff it hasn't seen before? That's a whole different kind of testing.
Right, a different methodology entirely. Okay, classical types. Got it. What's the second framework?
The second layer is technical implementation levels. This looks at the agent's architecture. How complex is it built, especially thinking about large language models and using external tools?
So what it can do, technically speaking.
Precisely. Level 1 is super simple, a basic responder, like a single-turn Q&A bot, ask a question, get an answer, done.
Okay.
But level 3, that's where evaluation gets really interesting. That's the tool calling agent.
Tool calling? Why is that such a leap? What makes a game changer for evaluation?
Because it has to reason before it acts. A level 3 agent doesn't just understand language. It has to decide if it needs an external tool, which tool to use, and how to use it.
Like deciding to check inventory via an API call.
Exactly. Maybe pull account info, run a database query. So you're not just testing if it understood the request. You have to test its judgment. Did it pick the right tool? Was it efficient? Or did it make 3 API calls when one would do?
Ah, I see. So the task could fail even if the language part was perfect, just because it chose the wrong tool or sequence.
Precisely. The reasoning is the failure point. And it gets even more complex at level 4, multi-agent systems, where you have multiple agents trying to coordinate.
Okay, so now you're evaluating the orchestration itself, the teamwork, basically.
You got it. Which leads us nicely into the third framework. Human Oversight Autonomy Levels. This is the governance angle. Think autonomous driving levels 1 to 5.
Right, level 1 being heavy human supervision.
Human is supervisor, yeah. Constant checks needed. All the way up to level 5, human is observer, where they basically just watch unless something goes very wrong.
This is where it clicks together for me. We have these 3 different ways to view the agent. And the crucial insight is that just because an agent is technically complex doesn't mean it gets a high level of autonomy.
That's the exact point. It's the gap that really trips people up. You could have a super smart, technically sophisticated level 3 tool calling agent, but because of safety rules or regulations or just company policy, you keep it on a really short leash. You operate it at autonomy level 1 with a human supervising every major step.
So it could do more, but you're deliberately holding it back.
Right. And understanding that mismatch the gap between its technical capability and its assigned autonomy, that's the absolute key to designing an evaluation plan that actually works.
Okay, that makes perfect sense. Which brings us to the evaluation strategy itself.
Okay.
How do we measure these things? You mentioned a dual-axis approach.
Yeah, think about evaluating a person at work. You look at two main things: their skills, their raw capabilities. Can they actually do the job?
Right. Technical skills.
And then you look at their judgment, their reliability, their trustworthiness. Can you count on them to make good decisions, especially when things get tricky?
Okay, skills and reliability.
We apply the same logic to AI agents. We use a dual-axis evaluation. One axis is technical capability, the other is autonomy and trust.
Let's break that down. Starting with technical capability, what are we measuring there? The KPIs.
Well, you got the basics, of course. Accuracy, success rate, does it actually achieve the goal? Latency, how fast is it? Throughput, how much work can it handle?
Standard performance metrics.
Pretty standard, yeah. But critically, also robustness. How does it react when you feed it garbage? Adversarial inputs designed to trick it or break it.
Okay, robustness is key. But you said earlier, just testing the final output isn't enough for these agents.
Absolutely not. You need both component testing, like unit tests for specific parts, say the planning module or the bit that chooses the tool.
Like looking under the hood.
Exactly. And you need to combine that with end-to-end evaluation. Testing the whole agent on realistic tasks, maybe complex ones that take several steps, several minutes even.
Let's go back to that level 3 tool calling agent again. If we're testing its technical capability, how's that different from just, standard API testing? We know how to test API calls.
But the failure mode is different. With old systems, we test if the API call worked correctly. With a level 3 agent, we have to test if it should have made that call in the first place. Was it the right decision?
The reasoning again.
Always the reasoning. So we need specific metrics. Tool selection accuracy. Efficiency, did it call 3 tools when only 1 was needed? Wasting time and money. And crucially, error handling and recovery. What if the API it calls returns an error? Does the agent just crash and burn?
Or does it recover? Maybe try something else. Or flag it for a human.
Exactly. That graceful recovery is vital. And to figure out why it failed in its reasoning,
You need to see its thought process.
you absolutely do. Trace tools, reasoning logs, whatever you call them,
Yeah.
they're indispensable. They log every internal step, every decision point.
Right.
Why did it choose that API? Why did it decide to escalate now? Without that trace, debugging is a nightmare.
Makes sense.
Okay.
Okay, that's the technical axis. Now let's flip to the other side. Autonomy and trust evaluation. This sounds less about code, more about people and process.
It definitely is. A really important concept here is trust calibration.
Trust calibration.
Yeah, it's all about making sure the user's level of trust in the agent perfectly matches the agent's actual reliability. This isn't just a nice to have, it's a massive liability issue.
How so?
Well, if users trust it too much, more than it deserves, you get over-reliance incidents, people letting the agent do things it shouldn't, leading to potentially costly mistakes.
Okay, that's bad.
But if they trust it too little, then you have underutilization. You've spent a fortune on this AI, and nobody uses its suggestions because they don't believe it works. That's also a failure, an expensive one.
So the goal is perfectly calibrated trust. Not too much, not too little. That reframes evaluation significantly. We're basically calibrating liability exposure.
That's a great way to put it. And when the agent is supposed to hand off to a human, or ask for help,
How do we measure that?
that needs metrics for conditional autonomy. The big one is escalation accuracy. The agent has to know its limits. It needs to recognize when a query is too sensitive, too weird, or outside its safety rules, and flag it for a human.
Right.
So you track false negatives when it should have escalated but didn't. That's dangerous. And false positives when it escalates something trivial, clogging up the human expert's time. You need to minimize both.
Okay. And when that handoff happens, does it go smoothly?
That's another metric, handoff success rates. When control passes from AI to human, or maybe back again, is all the necessary context preserved? Or does the human have to start from scratch? Seamless handoffs are crucial.
So if we bring those two axes together, technical capability and autonomy trust, using that matrix idea, let's take our level 3 tool calling agent again, and say we decide to run it at autonomy level 3, conditional autonomy, where it handles most things but escalates exceptions.
Perfect example. Your evaluation now has to hit both targets simultaneously. You need to confirm, 1, the technical side, Is it using the APIs correctly? Is the tool selection logic sound?
And two.
And two, the autonomy performance. Is it correctly identifying those exceptions? Did it recognize that really sensitive legal query it's not allowed to handle alone? And did it escalate successfully to the legal team? You need proof of both technical competence and sound judgment within its autonomy limits.
That really clarifies the dual challenge. Now let's zoom in on that human oversight part.
Ah,
As we move up the autonomy levels, the human's role changes dramatically, right? From micromanaging to just overseeing. How do the metrics have to change? We can't just keep measuring API success rates.
no way. The metrics completely shift focus. They move from measuring the agent's direct output to measuring its impact on the human workforce and the overall process.
Let's look at the different levels.
Okay, start at the bottom. Level 1, human as supervisor, checking everything.
Right. At level 1, the main thing you evaluate is supervisor workload impact. Does using this agent actually make the human supervisor's job easier or harder? Does it provide a real productivity boost?
So even if the agent is technically 95% accurate,
If the human has to spend ages correcting the other 5%, checking everything constantly, manually redoing stuff, then the agent is a failure. It's adding cognitive load, not reducing it. That's a critical evaluation point. That's powerful. An accurate agent can still be a net negative if it makes the human's job harder. Okay, contrast that with the top end. Level 5, human as observer, full autonomy.
at level 5, the human is basically hands-off unless there's a fire. So now you're measuring things like self-governance effectiveness, can it manage itself within its boundaries, and more profoundly, value creation beyond programming.
What does that mean?
It means, is the agent generating value in ways we didn't explicitly code for? How does it handle completely novel problems? Does it proactively spot and mitigate risks we didn't tell it about? You're evaluating its judgment and initiative, not just its ability to follow instructions.
Wow, that's a huge leap in what you're trying to measure. What about the middle ground? Level 2, human as operator, maybe helping a customer service agent.
At level 2, it's all about collaboration effectiveness. The key metric is usually user productivity improvement. Are your customer service folks handling, say, 20% more chats per hour because the AI is assisting them effectively?
Makes sense.
And you also track assistance accuracy. How often are the AI suggestions actually helpful and accepted by the human operator versus how often are they ignored or overridden? If overrides are high, the assistance isn't working.
Right, the operator isn't trusting it. And level 3, conditional autonomy, where it escalates exceptions.
Level 3 is all about knowing its limits. So the focus is back on safety and judgment. Escalation precision and recall are paramount. And uncertainty recognition, does it know when it's out of its depth? Can it identify scenarios it wasn't trained for and correctly say, I need help?
So its biggest failure mode there is being confidently wrong about something new.
Exactly. Overconfidence in the face of novelty is the danger zone for level 3.
Okay, one more. Level 4, human as approver. The human sets strategic goals or constraints, and the agent operates within them but needs approval for certain actions.
At level 4, evaluation focuses on strategic alignment. Is the agent consistently making decisions that align with the high-level goals set by the human? And risk parameter compliance, is it staying within the safety boundaries?
How do you measure that alignment easily?
A really simple, direct metric is the overturn rate. How often does the human approver have to step in and say, no, don't do that, or change the agent's proposed plan? If that rate is consistently high, it signals a lack of alignment or trust. The agent hasn't earned that level 4 autonomy yet.
It seems like across all these levels, clear communication from the agent is vital. It needs to be transparent about what it's doing and what it can't do.
Absolutely. That transparency, the agent saying things like, I'm not confident about this specific step, I recommend involving a human specialist, that's what builds and maintains calibrated trust.
And that enables what you called graduated autonomy.
Precisely. Evaluation isn't a one-time thing. It has to be continuous, cyclical. You develop, you test rigorously, you deploy to production, you monitor constantly, and you refine based on that monitoring. An agent only gets promoted to a higher autonomy level, less supervision, when the ongoing evaluation proves it has truly earned that trust.
So, summarizing that progressive approach, you start low, prioritizing technical correctness and minimizing risk. Then, as the agent proves itself through evaluation, you gradually increase autonomy, and the evaluation focus shifts more towards safety, trustworthiness, compliance, and ultimately, judgment.
That's the path. This dual-axis approach, looking at both technical skill and autonomous judgment, it's really the only responsible way to manage the kinds of risks these powerful agents introduce. We're not just testing software anymore, we're validating competence, reliability, and alignment over the long term.
That perfectly sums up this deep dive. Deploying these AI agents successfully demands this really rigorous, two-dimensional evaluation checking technical capability and human oversight readiness to make sure the system is solid, trustworthy, and actually delivering business value.
And looking ahead, as these agents get even more autonomous, maybe even start learning and adapting in ways we don't fully direct, well, the evaluation challenge is going to evolve again. It won't be enough just to check technical performance or rule compliance. Eventually, we're going to need ways to assess an agent's fundamental, maybe even moral, decision-making and its ongoing alignment with human values, even as it changes itself. That's the next frontier.
Assessing the moral compass of an AI. That is definitely a provocative thought for the future of trust in AI. Thank you for walking us through the complexities of AI agent evaluation today. We hope this helps all of you out there navigate the triple challenge.